Meena from Srishi to make a presentation. We have three speakers, Meena and Dr. Chakravarti and then Dr. Manna. Three speakers, yeah. So we have to leave. So then you go first. Sorry, Meena, we'll just take you first. Sorry, flights. Finally, flights determine everything. Yeah. So you take Mr. Manna and Kamini Patel for a presentation on participatory initiatives of craftsmen for frugal design and technology. This actually grew out of a workshop that the ministry had organized in January on looking at craft, science, art, and technology. And the presentation from IIT Kanpur, which somebody had made, this has led to this to a Center for Frugal Technology in IIT Kanpur, and this is an excellent example of how people like Professor Manna, who are leading researchers on metals and metallurgy, can combine their foundational knowledge and research with something for what can be done to redesign craft clusters and a creative economy there.
So while Komali starts, let me just admit very clearly that I'm the least competent person to talk about design, but certain observations made Mrs. Sharma believe that I could be useful. But from IIT Kanpur, we are going to start something which I said in the morning as well, that without any major infrastructural development, major investment, we can make a difference to the locality. And that's exactly what we mean by frugal innovation. So, Komati.
Good evening, everybody. I know it's been a very heavy dose of design today, so maybe one of the last few presentations. Hopefully, this would bring us back into the field where we have been working and speaking about of users and technologies, and moreover about social relevance of our practice itself. So this is a statement by Dr. Paul Pollock, who says, "I keep asking why 90% of the world's designers work exclusively on products for the richest 10% of the world's customers." Frankly, statements such as these have resulted into a lot of initiatives in this area, not only within India, but very interestingly, outside India too. So you have certainly a book like Fortune at the Bottom of the Pyramid, but you also have MIT's Design for the other 99%, the 90% of the world. You also have Frugal Digital that has come up as a department in Copenhagen Institute of Interaction Design. These initiatives that have taken place and are certainly trying to make a difference in India have been working pretty well. The difference that we found here was that though these initiatives seem to be working on ground, they seem to be forgetting something about our communities. And that is that the 90% of the world's customers have their own system of designing and producing, besides 10% of the world's designers who design for them. This means that this community that we're looking at is not only a skill tank, but this is also a think tank. And if we look at these communities from the point of view or from the perspective of the fact that these are also thinking skilled designers or thinking enabled designers, then we would like to participate with them as not communities on whom dictums are passed, on whom policies are made, but with whom designs and processes are exchanged. And therefore we think that we have a unique opportunity which West has certainly brought to our notice, but I think we are more capable of exploring it. One, because India has a very large informal production sector. In UP, the state in which I work in, it is said that we have almost 18 lakh craftsmen. It means that every fourth person in UP is a craftsman. 8% of India's GDP comes down from craft, from the manufacturing sector. And craft happens to be the second largest sector after agriculture in terms of employment generation for our country. And yet, despite the fact that since independence, many initiatives have been taken in this area, you still have craftsmen that are living in penury, you still have craftsmen who are living in very hazardous conditions. Moreover, the most well-intentioned attempts in this area have not survived in the community, especially after the designer has withdrawn. And that seems to be a cause of concern, that we have been spending money, we have been spending efforts in this area, and yet the efforts have not survived. Therefore, we thought that can we renegotiate our participation with the community and thus our work in this area. We have been attempting to learn how to collaborate with craft and other grassroots design communities in order to evolve an appropriate, acceptable, and affordable solution that can be manufactured, maintained, and disseminated within a community with largely its own resources and skill sets. And we would like to emphasize the fact that we are talking about within a community, especially given the fact that the word export was used quite a few times since morning today. The reason why we are saying this is that change has to be first and foremost acceptable and introduction to the community. It is only after that that we can speak about exports. And therefore, we have been looking at frugal design and technology in participation with craftsmen. In today's presentation, we would like to speak about a collaboration and case studies of 3 people. One is a craftsman, the second is an engineer, and the third is a designer. And for these 3 people, we are speaking about 3 studies. One is my own doctoral studies that I've been doing on Banarasi wooden toys. In terms of a designer, we would like to discuss a case study of Zeer by Muhammad Abba. And in terms of engineering, we would like to discuss a CSIR study on ceramic tile production. So let's begin with Banarasi wooden toys, a place where I've been working for past 5 years for my doctoral studies. The toys that you're seeing on the screen, the left-hand side are toys that have already been in existence, and they are either static toys or they have a movement which is only a 2-part movement. With the intervention that we did in this particular community, we realized that the craftsmen on their own, by just small triggers that we had provided, were able to do the 3rd design on their own by including a 3-part movement. The interesting thing about this 3-part movement was, does this have an arrow to go onto the video?
There's an animation in that.
No, but there's no arrow for the video, right? No. I need a pointer, yeah. There's no pointer, right?
There's an
So the
animation.
videos won't
She's
work.
looking for that.
Okay, so the reason to show this is just to tell you that there have been particular mechanisms that they're using, and they were able to achieve a 3-part movement, not just 3 but also a 4-part movement later. Obviously, this is not one of the most this doesn't seem to work. Next slide, I think. Okay, this obviously does not seem to be one of the most interesting mechanisms to be looked at, but these are mechanisms that the craftsmen seem to be evolving on their own to a community where we are looking at and saying that this is a community that is only skill oriented, is trying to show you that they can actually work on their own. And why do we think that that our intervention worked? One, we think that we were able to provide correct, appropriate triggers for innovation. But the ideation process that was followed was based on traditional skills and designs. We were able to use, or the craftsmen themselves used, locally available materials and tools. We were able to map this entire process on manufacturing techniques of the community itself. The improvisations were made by the community. Moreover, the repairs of these toys were also made by the community. And this repair factor brings me to an interesting note. I think one of the most interesting thing to look at in the ecosystem of a shoe made in India is that besides the fact that you have somebody who makes the shoe, you also have a mochi who repairs a shoe, which cannot be done with a Nike shoe in the country. And that part of the ecosystem needs to be remembered when we're looking at product design here. So we looked at product diffusion, which seems to have been integral in the community system itself. And certainly all this worked because we had consistent orders for purchase of this particular product. So we believe that the kind of design and technology that we are looking at for crafts is different. For one, we think design and technologies need to be developed whose ecosystem lies within the community and not outside the community. And the second part of it is that design and technology needs to be replicable. That technologies need to be replicated not by a firm outside, but technology needs to be replicated by the people themselves. And a very good example of this is Zeer itself. Zeer is a evaporative cooler that was designed by Mohammed Bahaba, and it brought almost a revolutionary change in Egypt for the farmers. This is a cooler which can be purchased for about 70 rupees, is made with a production cost of 60 rupees, and increases the lifespan of vegetables on an average by about 8 days. Both the pots are anyways being made by craftsmen around, and all that it requires is the idea that you can put sand and water in between. The evaporation would lead to cooling in the inside pot. And from there on, as we move on from craftsman to the designer, the third part that we thought we could integrate very closely to this was the idea of engineering itself, which I think Professor Manna would take up.
Well, this basically is borrowed from a CSR experience, primarily because this very amply explains what we mean by frugal innovation. This is an example where I'm referring to Morvi in Gujarat. Certain type of glaze style which used to use 28% of an imported variety of clay could be substituted by a local clay with certain amount of compositional adjustment by the scientists of CSR in Naroda Center. And this simple substitution brought the use from 20 weight percent to less than 1 weight percent of Ukrainian clay, which means quite a lot of cost reduction and also dependence on imported substance decreased. And because of one single intervention, earlier where used to be only 4 units, now today there are 14 units, today there are 64 units, and each are making a higher profit margin by 3.56 crore per annum per unit. So that's a huge amount of difference that has made to a local community. I chose this slide primarily because this was shown to the Prime Minister in the CSR Society meeting, and even Dr. Sam Pitroda also is aware of this intervention. So this is just an example where simple scientific intervention can make a lot of difference to the artisans or local industry. Next one. Next one, please. Komodi. This. Okay, if you look at these beautiful tiles, there are a lot of interesting features. First of all, you would expect bright color. You would expect the color to last. There's very nice and very precise engineering symmetry involved, because in many cases these are 3-4 different parts put together. So when you fix them on the floor or wall, they actually should maintain the symmetry. And for doing all these, there is a very large amount of science behind it, which is the pressure you apply for pressing, the temperature, the time, combination, the heat treatment, the diffusion involved. So quite a bit of heat and mass transfer involved. And most importantly, for strength and other things, these tiles, they do not go through very rigorous testing and certification. But many of them actually are exported, and that actually earns a lot of money for the country. So I have picked up these floor tiles, similarly the roof tiles, which is a very low-end product, but rural India uses them extensively. And a simple intervention there with some substitution with fly ash, which is a very major industrial waste. If that can be utilized, it not only reduces the weight, but it also makes the tile much more durable. Similarly, the blue pottery, one of the colleagues here did make a mention. The blue pottery that uses the blue bright color comes from lead oxide, which is highly toxic. And these artisans are not well trained, or they are not quite aware what are the consequences of inhaling this lead oxide or burning them in fire. And the way they dispose this waste is also extremely dangerous. So there again, scientific intervention is absolutely necessary. Then these sanitary products that you are seeing, this actually could be produced with local clay. In most of the cases, for that we use a special kaolinite, which is expensive. But they can be done with local clay, and this alone can actually create a model which can create a nice ecosystem within certain villages, within, let's say, about 50 kilometers. So could be produced, and an industry can come up, and at the same time, the sanitation problem of the rural India can also be taken care. So basically, the users and the producers could be within the same ecosystem. Next one. These beautiful bangles with bright colors, they are characteristic features of this area, Firozabad, Varanasi, even Khurja to some extent, and so on. These glasses again use very small amount of dopants, could be cobalt, could be arsenic, and so on, which are again toxic in nature. And the most important thing is these artisans actually are not quite, they have a lump of glass and they use that over a period of time, and they don't realize that the glass making itself, I mean, they realize through experiences, they don't have the scientific knowledge that this long chain silicate network to put the right amount of dopant and make them homogeneously distributed throughout is not a very easy task. They can manage to do it only within a small volume, but when they do it number of times and over a larger volume, then inhomogeneities crop up and the products get rejected. Brassware is another very bright example. Moradabad is world famous for this. All these carvings and manna and all these artworks actually can last longer if they can be prevented from corrosion, weathering. And that can be done very easily with certain amount of coating, which these people not quite aware of, because that coating that is not a metallic coating but of a polymer or resin coating. So for all these things, we need to actually go to these people and train them up. At the bottom, if you look at this red hot iron piece, basically this is how the ironsmith, they make their tools and accessories. Now, there is a huge lot of science behind that, because the temperature to which you subject and the temperature where you start deforming and where you finish, if it is not within the certain precise temperature range, then you don't get the right kind of hardness and strength, which means the tool will not perform to the extent it's desired, the life will be shorter, and there will be defects. Even the residual stress at the curved portion that you're seeing at the bottom plays a major role in the overall life of the product made. Now, artisans don't understand what is residual stress or what is the austenitizing temperature. They simply go by their experience. Looking at the color of the implement, they know whether it's 768 or 790 or something like that. But simple intervention of teaching them how to use, of just, for example, using a nice thermocouple, and which doesn't cost much, and showing them that the bucket full of water that they use should be replenished after some time, otherwise the quenching rate is reduced. These kind of things can certainly help them a lot. So next one. So basically, the way we understand frugal innovation is the following: that we don't have to go around or think a lot about it. We can just look around our local areas and identify places. In UP alone, there are about 20 lakh artisans working, and UP earns 45% of the total foreign exchange earned by exporting artifacts or handicrafts. And these handicrafts are all made up of various kinds of solid materials. They don't have a formal training. They simply use traditional knowledge, and they are often dependent on the local lenders and brokers. No knowledge about marketing, no provision for testing and evaluation with which they can actually get a certificate to export. So all these interventions can be done by without investing a lot on creating new infrastructure with the existing infrastructure. And most important thing is there's a huge scope of export and business awaited in this. So this is exactly what we would like to propose as our definition for Center for Frugal Technology. And I'm sure this is a doable model with not just Kanpur but many other institutes of higher learning. So I think that's all, but I would just end saying that we believe that designing for and with designers at the grassroots level is not only an economically lucrative segment, but also an untapped thinking and manufacturing resource of India. I end up saying that all solid objects can be of two types. One where you have long range periodicity, which we call crystalline, and the other one which doesn't have long range periodicity. But you think carefully, nature teaches us exactly what symmetry means and what precision nature can give us. We just need to learn from nature and replicate that in all kinds of synthetic products that we sell in the market as artists, as art objects. Thank you very much.